Good day, everyone. Today, we're going to go deep in the unit circle and we're going to touch on the Pythagorean. And I'm teaching on the day of November 11th, or A Day, and November the 12th. I am doing this in particular the dates so you guys could keep up with pieces of information. All right, announcements. This week, I do want to see what you guys are working with, so quizzes are the thing to see what's up. Remember, stay ready so you don't have to get ready. I tell you guys this, but many of you guys don't tend to grasp what I mean by that. I have to see what you know. Demonstrate what you know. Most of you are not adhering to that. Thus, the low grades or the stagnant grades. If you want your grades to increase, you gotta do a little bit much more than just turn in, pieces of sheet of paper from homework. You have to be fully involved in the participation. You have to really, really get yourself involved. All right, anytime you are absent, the district have said something about this. I am allowed to record a 0x for when you are absent, excuse or not. So if you are absent, and a 0x there, you got your excuse, cool, I will allow you to make it up, depending on the situation. But if you got no excuse, it's a 0. Maker work is not going to consist of a worksheet because I know how you guys are with worksheets. You go copy the answers instead of you trying to do the work and trying to understand it. You copy stuff down. And then when it comes down to taking the test, you don't know what to do. So, you know, that's why, when you do maker work, of course it's a quiz. I give you a little maker work to just practice to prepare you for the quiz, but I am not. We're not doing worksheets because you're gonna miss the point. Failure to make up the work will result into a permanent 0F. I am gonna give y'all a test before Thanksgiving, so y'all please don't skip. Semester exam. Alright, to be exempt for my class, you have to have both an 85B and a 20 on the practice ACT. Practice ACT will be taken before the midterm. Possible open notes on the midterm depends on what y'all guys do. Now, what I mean is, you have to show me what you really. If you gotta be hungry to want to learn. Many of you guys don't have that hunger or the drive. You just here, and it's about anything else but the school work. And it's unfortunate because you guys do. I do offer tutoring, and few of you guys do take advantage of what's being offered. But one thing else I want to talk to you guys about, what you do in my classroom is a reflection of your grades. Anytime you choose to sneak on your phone, do all this stuff, of course, I'm not going to fight y'all about it because y'all know what's happening. But you choosing to not be a part of the participation process, so I cannot honor you in terms of that grade. So, when your grade's still looking like, man, I still got the same grade I had the first time, it's because you're not doing what I needs to see. You know, you guys gotta start doing better. Otherwise, this ain't gonna work. You're gonna either pass me within the 4 9 weeks, or you're gonna have 6 or 8, or you're gonna have to have 8 9 weeks of me. So it's depending on what you guys want to do. Right. Smartphones, like I said, I see again. Y'all already know how it gets down. Sneakiness hinder grades. Nonsense will hinder grades. Disruption will hinder grades. Check Google Classroom by 3:50 p.m. is to determine if I'm going to tutor. So again, tutoring, I want to address this from you guys. It is not an expectation. It's a privilege. That's me rewarding you for, okay, I see you trying. I know you trying. I know you don't understand the material, but I know you really, really, really trying. And you don't have to say, oh, Miss Howard, I'm trying. I know you trying. So what happens is, I'm like, okay, well, why don't you all come to and let's practice together? That's when I offer it to you. Binder checks, notebook check. I do want to address this with y'all too. Notebook check, again, that depends on how I'm feeling. That's not something that, oh, is owed to you. If you don't care, I won't give a notebook check. Notebook check is like, okay, well, you know what? I know you're struggling in my class. Here. But because you've been doing the right thing, let me, show you a little grace and compassion. If you can't show me the grace, how do you expect for me to give you the grace? So, some classes will have notebook checks, some will not. All right? Tutoring, when you do tutoring, is for you to discuss from the heart. That's for you to, whatever concerns you're having, to talk about so someone could help you. Because there are some people who really take advantage of the tutoring and really, growing from it. All right. Our objective is to review important angles at Pythagorean proofs, use reference angles and the coordinate plane to find trig ratios, and to convert from radians to degrees. Those are our three things. All right. You got a quiz. Now, if you got 5 tutorings, you are exempt. So when you go to your progress report or J Chems when you see E, E means that you've been exempt, meaning that it's not going to go against you. It's not going to, give you bonus points and nothing like that. All right, let's review radicals. Not really radicals, but let's review these important angles. What are these 3 important angles which, you know, builds up the unit circle? Pause the video and think on that. All right, let's review. We got third degree angle, 45 and 60. These are the things that build up on the unit circle. Now, additional thing that you have to know, you gotta know each side. So we gotta know that the third degree angle, the long leg is gonna be horizontal, so that's gonna be square root of 3. The hypotenuse or the radius is always 2, and then the short leg is always 1. All right, and these are just things that you have to remember and know. Remember these things. These are something for you to remember. All right, let's do the 60. We know that if we flip the third degree angle, we know that it becomes the 60. And so that means that your short leg becomes 1, and that 1 going to be right here. And then the long leg is going to be standing up. And of course the hypotenuse is going to be exactly the same. So 1 square root 3, 2. But for the 45 degrees, we both know that both legs are 1, and because it's 45, you have square root of 2. Now, remember, square root of 2 is because, 90 divided by 2 gives you 45. And we say 3 because 30 goes up by 3, gives you that 30, 60, 90. All right. So pause this video and try out this video. This problem. All right. So you realize that cotangent is between 0 and 90 degrees. And you know this is in quadrant 1. So everything's positive. But you know to find cosecant like this, you have to find your Pythagorean. So we know that cotangent is adjacent over opposite. Or maybe I'm tripping. Yeah, adjacent over opposite. That's cotangent. I got those numbers in the wrong place. But at the end of the day, it still doesn't really matter because when we use our Pythagorean, that's not it. 16 plus 9 because 4 squared plus 3 squared is going to give you 25, and when you square root 25, it's going to give you 5. Now we can find cosecant, and we know that cosecant is the inverse of sine. So that's going to be hypotenuse, which is 5, over opposite, which is 4. So that's cosecant. All right. Just remember, if I actually name the coordinates of the unit circle, it's always going to be cosine and sine. All right. Now, I have discussed this to you by proving the Pythagorean theorem. We did this twice actually, so I'm not going to talk about this. However, it is imperative for you to write down all of this. I'm not discussing it because we already talked about this. Also, I'm not going to talk about this either, proving that tangent equals sine over cosine. We already proved all of this because we talked about the trig ratios, and then we talked about the division of rational numbers. Things cancel out. Y over x, which tangent equals sine over cosine. I'm not going no further explanation on this because I talked about it already. All right, don't forget our objective. Talk about point angles we did, and discuss the Pythagorean proofs, which I showed you, and we talked about it at length in class. We're going to talk about using the reference angle and use the coordinates to find trig ratios. And then we'll convert radians to degrees. So let's look at 0, 90, 180, and 270 right quick. We know that 0 degrees is also equal to 360 degrees. What I mean is they're going to have the same particular measurements because, when you start at 0 and we finish at 360, you're in the same position when you're going around the circle. So, with that being said, because you're dealing with a unit circle, you got radius. So the radius of 0 and 360 is going to be 1, and is for all the angles here. All of these have a radius of 1. So each one has a radius of 1. That's throughout the whole entire unit circle. So that's why you have this coordinate pair of 1 comma 0. And then at 90 degrees, you still got the uh, radius to be 1, but it's on the y coordinate, so that's why it's y. But here at 180, the radius is still 1, but because you're in quadrant 2, it's going to be negative 1. And then in quadrant 3, 270, your radius is still 1, but because it's dealing with the negatives of quadrant 3, it's negative 1. Alright, special fact about 0, 90, 180, 270, and of course, 0 goes with 360. They will have the same exact measures. Alright, remember the unit circle is composed of the equation of the circle. Alright, so let's move on. Alright, so we're going to find the basic trig ratio of 90 degrees. So we know when we're at 90 degrees, the radius from the center to the outer part of the circle is 1. And because it's going vertical, it's going to be for the y. So that's going to be 0, comma 1. So remember, our trig coordinates of the unit circle is going to be cosine and sine. So that means we already know what cosine and sine is. So in this case, because you are given a coordinate pair, 0 and 1, especially when it comes to the zeros and the ones, cosine is going to be 0 and sine is going to be 1. So sine of 0 is 1. Cosine of 0 is 0. I'm sorry. Sine of 90 degrees is 1. Because that's what we're trying to deal with. We're trying to find the particular measurements of 90 degrees. Cosine of 90 degrees is 0. Tangent, remember, is comprised of sine over cosine. And when we do that, 1 divided by 0, 0 is undefined. Now, you may not know this, but we're going to talk about it. We're going to have to define a rational number. So you guys call it fractions, but because you guys are in Algebra 2, you can't call rations no more. A rational number is a quotient of two integers, p and q. And we choose p and q just for any letters. You could use m and n, t and h. Whatever letters you want to use, you could do that. But those letters that are in a quotient, p divided by q, that just said, you have a quotient of rational numbers. So, q cannot equal 0 because if it does, it becomes undefined. This is a point definition. Yeah, I'm going to be asking you about that. Alright, so let's find the basic trig ratio of 180 degrees. Now, we know that the radius is 1, so it's going to be negative 1. And we know that cosine is negative and sine is 0. So let's build, and we know that tangent is going to be sine over cosine. So let's do it. So sine of 180 degrees is 0. Cosine of 180 degrees is negative 1. And tangent is sine divided by cosine, which is 0 divided by 1 is 0. Alright? So let's touch our reference angles. You guys know how to do this. We practiced this already. So, in the previous class, we used 30, 45, and 60 to build up all the reference angles for quadrants 2 to 4. And we know we subtract the angles from either 180 or 360, we know that the answer is always going to be 30, 45, or 60. It's one out of those three. All right. And so, like if I was to do 120 degrees, because that's in quadrant 2, 180 minus 120 is 60. For 210, because that's in quadrant 3, 210 minus 180. And then, if I was to do 300, it'd be 360 because it's in quadrant 4, minus 300 equals 60. And that's how you find those reference angles. So why don't you pause and try these videos out? Try these problems out and see what you come up with by following these particular models here, here, and here. I'm not going over this for you though, but I think you get the hang of it if you was to try it. All right, so let's build the basic trig ratios for 30 degrees. Pause the video and see what you can do. All right, so let's talk. So you know that a third degree, the long leg is going to be horizontally or the x value. The short leg is going to be your y because it's third degrees. And your hypotenuse is always going to be your radius. So long leg is square root 3, short leg is 1, hypotenuse is 2. So sine of 30 is 1/2, cosine of square root 3 over 2, and tangent is actually square root 3 over 3 if you would have did your work correctly. If you are still struggling with this rational denominators, just review previous work that we did. It's recorded, y'all. All right. Now, let's try to do 150. Now, to do the true ratio of 150, you must find the reference angle of 150. Since 150 is between 90 and 180, it's in quadrant 2. So, if I subtract 180 from 150, I actually do get 30 degrees. And of course, our measurements are the same because since it's a 30-degree triangle, it's going to be all the same. The only difference is because I'm in quadrant 2, we know something's going to be negative. So, horizontally, because cosine is going to be negative, so because this deal is x and x is horizontal, square root of negative 3 is going to be negative. So, negative square root of 3. So now let's do our two ratios of this. So cosine is going to be negative square root 3 over 2. But tangent is still going to be positive because you're in quadrant 2. Sine is going to be positive 1/2 because you're in quadrant 2. I'm sorry, y'all. Tangent is going to be negative square root 3 over 3. Alright, why don't you try those problems out and just see what you can come up with on your own. Alright, remember, all we trying to do is build using what we know about the 30, 45, 60 to find reference angles and find their values. We went and found the cosine and sine of negative 150. I mean 150 because we realized that 150 has a reference angle of 30. And we realized cosine being your x coordinate is going to be negative because you're in quadrant 2. So just keep that in mind. These are some trig ratios that you could just keep if you need them. All right. Now here, it actually was determine the side of angle theta is in the standing position and intersects the unit circle at 65 over 97, 72 over 97. What's cosine of theta? And we know cosine is your x value, so 65 over 97 is your answer. I know I went too fast on that one. I want you to try this one on your own and just see what you can come up with. Alright, the last thing we're going to do is conversions. So look, let the vertex of an angle be at the origin, with one side of an angle on the positive x-axis. The radian measure of an angle is the measure of intercepted arc length on a circle of radius 1. To convert between degrees and radian measures, which I'll explain to you a little bit later. But before we go on to do that, we got to also talk about this. Angles can be measured in radians. To define a radian, consider a circle with a radius centered at the origin, as shown. One radian is the measure of an angle in the standing position whose terminal side intercepts an arc length r. So we try to worry about building the radians here from the degrees. All right, these are critical. All right, so the radius is the angle made when the radius is wrapped around a circle called the radian. The radian is a pure measure based on the radius of a circle. The radian is made when we take the radius and wrap it around the circle. Alright, so here's some facts. Because the circumference of a circle is 2 pi radius, there are 2 radians in a full circle, so the degree measure and radian measure are related by the equation. So 360 equals 2 radians, or 180 equals a radians. Alright, 1 radian is 57.3, so keep that in mind. Alright, so here's what I want to end it with. So to convert between radians and degrees, you have to do the following. From degrees to radians, divide by 180. Alright, so for radians degrees, you're going to multiply the radian measure by the degree. So it's all division naturally. So let's practice. So we gotta show the radians measures are equals to each of the degrees. So you got the degrees and the radians. So let's do it. So to get 30 and to find the radians of that, you have to do the following. So 30 pi divided by 180. And we simplify all that. That is going to be 3 over 18, which you can simplify that even further from 1/6. And 1/6 is just pi over 6 for 30 degrees. Alright? And that's me going from degree to radians. Alright, Let's do pi over 6. Because now I want you guys to see, because I'm going back from pi over 6, from radians to degrees. So let's do it. So you're going to multiply it by 180. So 180 divided by 6 is 30 degrees. You see how I went from one direction to the other direction? And this is how I know 30 degrees is has the radius of pi over 6. Alright, so let's do 45 degrees right quick. So we're going to go from here to here and vice versa. So 45 degrees, to convert that to radians, you're going to go 45 over 180. And when you simplify this, you're going to get 1/4, which we know is going to be pi over 4, because you have to have pi there. Alright, so I'm going to go pi over 4 to get 45 degrees. So pi over 4, if I multiply this by 180, I get 180 divided by 4. And when I divide that, I'm going to get 45. That's how I prove those two things. Alright, so let's do 60. So 60, I'm going both ways. So 60 degrees is going to be 60 divided by 180. I'm going from degrees to radians, and when I do that, 6 over 18 we know that to be 1/3, so that's going to be pi over 3. And that's how I check that out. And I'm going from radians to degrees, so pi over 3 times 180. So 180 over 3 is 60 degrees. Alright? Just make sure that you pay attention to what we're doing in class. Come tutor and get this practice on. Watch all the videos on this so you can be alright.